Okay, so what I want to go through are some of the Chapter 1A notes. Different classes were in different places, so what I'm going to do is I'm going to start on page 2. Every class got through page 1. So here's page 2. It talks about the growth in the numbers of prisoners from 1980 to 2000, and then it asks, is the proportion of female prisoners increasing? And if you look at the data here, well, the number of female prisoners is increasing, but we need the proportion. So the proportion, we're going to look at females to total. So in 1980, there were 12,000 females to 316,000 total. And that comes out to be 0.038. And if we do this for all of them, 21 out of 480 in 1985, that comes out to be 0.044. If we check all of these here, 41 over 740, that ends up being 0.055. 64 over 1085 equals 0.059. And 92 over 1382 is 0.067. So this is, 3.8%, 4.4%. And if you notice here, you can say yes, the proportion of female prisoners is increasing. Okay. So let's go on. Down here now, instead of just looking at data, so numerical methods, we're going to try an algebraic method. So that means trying to come up with a formula first. So in this problem, everything is discounted 25%, and the discount's taken at the sales counter, and then after the discount, you add 7% sales tax. So find a formula that represents the final cost T in terms of P. P is the original price. Okay, so first let's look at this. So T is a function of P. So, I'm going to write it like this. You should be thinking in terms of this. F of x equals something. This is T of P, not T times P, right? So this is total cost depends on price. And first, the price gets discounted 25%. So you can think of that a couple different ways. You can think of it as you take the original price and you subtract 25%, right, 0.25 of it. Or you can also think, well, that's 75% of the original price, right? So here's 0.75p. So that's the original price. Okay. Or that's the price after the discount. Then we've got to add the 7% sales tax. So it's 7% tax on this price, the discounted price. So I need to add to this 7% of this value. So that's 0.07 of 0.75p. Now, if you wanted to simplify this a little bit, you could. You could take out a 0.75p, and you're left with 1 plus 0.07. So that gives you 1.07 times 0.75p. Doesn't really matter to me if you simplify that or not. So that would be the final cost T in terms of P. Okay, so use the formula you found in A to figure out if you can buy a shirt that's originally $36.99 if you only have $30. Okay, well, if it's if it's $36.99 originally, then that's your P. So I'm going to look at the cost, the total cost, if the price was $36.99. So if I plug into, I'll use this simplified formula here, 1.07 times 0.75 times 36.99. And if you work that out, you get $29.68. Since you have $30 to spend and it's only $29.68, then yes, you can afford it. Okay, so moving on. Example 4. We've got a pizzeria, sells rectangular 18 by 24 inch pizzas for the same price as a round pizza with a 24-inch diameter. So that means the radius is 12. So both pizzas have the same thickness. Which option gives you the most pizza for your money? So that means we're going to compare areas. So area of the rectangle is just going to be 18 times 24, which comes out to be 432. And since they're inches, the area is inches squared. And then over here, the area of the circular pizza is going to be pi 12 squared, pi r squared. So 144 pi ends up being 452.39 roughly. So this one's more than this one, and since they cost the same, the circular pizza is the better buy. Unless for some reason you hate circles. Alright, so example 5. Engineers at an auto manufacturer pay 8 cents per mile plus 25 bucks per day to road test their vehicles. Okay, so let's come up with a model before we plug in some numbers here for A and B. So the pay, I'm going to call P, the pay, equals total pay. I'm going to say that little m will be the number of miles that you drove. And then the other thing that you need is how many days did you drive. So D would be number of days. So P really depends on two things. It depends on M and D. So I'm going to write this. P is a function of M and D together. Now I know that I get $25 per day. So 25 times D tells me how much I got paid just to drive for a number of days. And then if I drove m miles and each one pays 8 cents, then I'm going to add to it 0.08 m, right? So let's see. How much did the auto manufacturer pay Sally to drive 440 miles in one day? Okay, so D is 1, M is 440, and we can plug those things in. So P of 440, comma 1. So M I'm going to replace with 440, D I'm going to replace with 1. It's 25 times 1 plus 0.08 times 440. And that ends up being, let's see, $60.20. Okay. John earned $93 test driving a new car in one day. Okay, so how far did he drive? Okay, so we're looking for the pay. I know that D is 1. Oh no, we're not looking for the pay. I know that the pay is 93. And I know that D is 1. So I'm going to set up my equation. 93 is 25 times 1 plus 0.08 times M, because now I'm looking for how many miles it drove. So if you work this out, you're going to get 68 equals 0.08 M. M equals 850. So then your answer is going to be he drove 850 miles. 850 miles is an awful long way to drive and only get paid $93. So hopefully it was a pretty sweet car. Okay, one more thing. The zero factor property. We're not going to do the last page in this video. So zero factor property is something we talked about in class. A, B equals 0 only when A is 0 or B is 0, which also in math means they could both be 0. Okay, so we talked about some examples. One of the things you can't do is this. If I say that equals 2, then I've seen some students writing this. So x plus 2 equals 2 or x minus 4 equals 2. Well, that's not necessarily true, because what if this was like -1 and this was -2? Well, then neither of these statements has to be true, right? It only works when this value is 0. So a lot of problems that we do, you end up having to get something to equal 0, right? An expression equals 0. and then you solve that. So there are a few different ways of saying the same thing. One is if a is a real number and it solves f of x equals 0. So that means you've got some function with a bunch of x terms in it. You know, whatever you want here. Whoops, sorry. Whatever you want here. And you're setting it equal to 0. So it equals 0. And the solution here, you're saying one of the solutions is a. So another word for solution when you have an equation that equals 0, you can call it a solution or you can call it a root. If you're looking at y equals f of x, really what you're solving is when it's 0. So you can also call it a 0 of y equals f of x. Right? Then you're essentially plugging in 0 for the y. And then if you graphed it, right, then the thing you're looking at is where the intercepts are. Because remember, if you're trying to find out when y is 0, that's when it crosses the x-axis. So x-intercept is another way of interpreting this. Let's look at the last problem here on this page. Example 6, find all real numbers for which 6x cubed minus 11x squared equals 10x. So if we follow along with what we wrote here, an expression should equal 0. That's how we solve a lot of things. And then let's get everything on one side. Minus 11x squared minus 10x equals 0. This one we'll do algebraically because you can factor out an x. So you get 6x squared minus 11x minus 10 equals 0. And then this actually factors. So this factors into 2x minus 5 and 3x plus 2. Okay, now this is like the a times b equals 0, but really it's a times b times c equals 0. Still the same properties apply. So x equals 0 or x equals, that would be 5 over 2, or x equals negative 2 over 3. So we get 3 answers. If you wanted to write it using interval notation, well, it's not a full interval, it's just specific points. So instead of putting it in like these brackets or parentheses, instead you use a set symbol, the curly brackets, 0, 5 halves, negative 2/3. Typically you want to put them in correct order, you know, from least to greatest. So negative 2/3, 0, 5 halves. That's probably the best way of writing it. And that's it.